Hello, Mr. Stole here from your tutors. So guys, I encourage you guys to subscribe what you call on my channel, and also what you call follow us on Facebook and Instagram. Okay, now today we're going to look into the third class of finance and grade 12. And in the third class we're looking at present value annuity. We are still on annuities, present value annuities. So let's dig in and see how far we can go today. Okay, you now know how I like my classes. My classes, I want to start with questions, guys. Why do I want to start questions? So that you can see, are you understanding the topic or not? But now, again, if you're not understanding it, the class is for you. But after listening to the class, you need to come back and attempt and see if you're actually getting it right. Okay, then you can attempt question papers and everything. But now let's dig in and see how far we can go today. Now, we need to understand what is present value annuities or reducing balance loan. You take a loan and you need to pay it back on on regular payments, which are consistent. And now when you're saying regular payments, can be monthly, it can be half yearly, it can be weekly as well, but you are paying it back. But now you know the value that you have borrowed. So in this case, we are using present value formula annuity. Then when the loan is paid off, the loan itself, the amount that you borrowed, and the interest, we call that the loan has been amortized. Okay, amortized means it has been paid off. Now let's look at this and see how it's supposed to work when it comes to loans. Because now we know with future value annuities on the previous class what should be done. Now, when you have this, let's just look at the present value. It's going to be equals to X, which represent your installments, okay, equal installments or regular payments. Then we have got to let's see here, 1 minus 1 plus our I to the power negative n all over our I. So here is our present value. This is your regular payments. Or you can call it installments and everything. And those can be monthly, remember, can be weekly, can be half yearly as well. Then this one here is our interest rate. And remember, it's guided by number of compounding periods per year. So if it's same annually, that is over 2. If it's if it's monthly, it's actually divided by 12. Then here we have got our n. Our n is number of compounding periods. Number of compounding periods. Number of compounding periods. In this case, you can say you multiply by 12 when you know that it's a number of years times 12 if it's compounded monthly. Now let's look at what matters most in this class. In this class, we need to understand that when you are taking a loan, so we've got T0, you take your loan at T0. We have got T1, you're paying back. T2 goes on like that up until Tn. What you need to understand, when it comes to loans now, you need to have a gap. So what is this gap? Gap is between the time of borrowing and time of starting to paying back. So that gap is what we have here. Now, in this case, we call it the gap. So it must be a gap of 1 compounding period. It must be a gap of what? 1 compounding period. So you need to be having, it can be a gap of a month. That's what you need to understand. So it needs to be gap of compounding period. That's what we need to understand here when it comes to what call loans. Because if you are to say, let's say you are borrowing money or you are buying a car on on credit, then what happens now is that you are paying back, you are taking money from there, or you are paying deposit. If you pay deposit, in that case, you are paying it on T0. We call that deposit. Whatever amount that is paid there. So let's say you are starting to pay 5,000, 5,000 in this case. But if you are to have a scenario where you are saying at T0, you pay 5,000. This is referred to as a deposit. It's a deposit, so it's subtracted already from the amount that you are borrowed. So in that case, now we don't need to consider it that much. We need to subtract it from the total amount. That's it. So that's what you need to understand. So that's what you just need to watch out, guys, that there should be a gap. But we'll understand when we actually get into the questions here. Now, David takes out a bank loan in order to pay for his new car. He repays the loan by means of monthly payments of 5,500 for a period of 5 years, starting 1 month after the granting of the loan. So this, in this case here, it's very much fine. It's 1 month after, and we know that that's our gap that we want. The interest rate is 21% per annum compounded monthly. Calculate the purchase price for this new car. So here we're looking for the present value. So PV is equal to X bracket 1 plus 1 minus 1 plus our I, the power of n, not n, negative n, all over our I. Now, in this case, our PV, we have it. We don't have it. We are looking for it. What about our X? Our X, we have it. What is our X? In this case, our X is the regular payments of what? 5,500. Now, what about our I? Our I, we also have it. It's 21%, which is 0.21 over 12 number of compounding periods. What about our N? Our N in this case here, how many N here do we have? It's going to be for 5 years and monthly. So it's going to be 5 times 12. And what is 5 times 12? I think it's 60. 5 times 12. It's 60. So we have got our 60 there. Okay. So we have everything we need now. Sorry about that. Now, then we come here and say, okay, what is our PV? We substitute the values now. We substitute the values because in this case here, we are having the gap that we want. Let me just put it here. T0, we're not paying anything. T1, we started paying 5,500. T2, 5,500 again. It's T2 until Tn, which T60, which is going to be 5,000, 500. Then the loan is actually paid up. So in this case here, this is the gap that we want, and it's fine like that. Okay, then we can substitute the values here. PV is equal, let's substitute the values, put in the values and find the answer. Okay. And so if we put in our values there, our X, we have everything there, our negative 60 there, then this is our final answer that you get. So you just need to punch it as it is, that you see, as you see it on the, what is it? On the, what is it? On the calculator there. Okay. So you just punch it as you see it, as you also put it in your answer. Okay. Now let's look into the second question here and see what is it that we have now. Daniel takes out a loan to pay for his new car. He repays an initial deposit. He pays an initial deposit of 15,000. He then makes monthly payments for a period of 5 years, starting 1 month after granting of the loan. The interest rate is 19.5% per annum compounded monthly. Calculate the monthly payments if the car originally cost him 225,000. So here we have got something like this here. That's our timeline there, and our T0, we have got T1, sorry, T2 goes on up until T. This one is made for 5 years in compounding monthly. It's going to be T60 as well, just like the previous one. Okay, then here it's making payments of what? Regular payments of we don't know. So it's putting X, it's starting here to put the X, but on this point here, he paid how much? 15,000. And what we call this one here? We call it the deposit. So if it is a deposit, we have to subtract it from the total, from the original value or the value of the loan. So we need to subtract it from the PV. So what we have in this case here, we have got the PV, which is equals to 225,000. And what do we have again? We have got the, what is it? The X we don't have. We are looking for it. What is our I? Our I is 0.195 over 12 because compounded monthly. What is our N? Our N is 60. Then we have almost everything that we want there. Now, so what do we need to do? What is the PV in this case? So PV is going to be 225 minus the deposit. Minus the deposit, which is 15,000, which is going to be equal to, because remember PV, the present value of the loan. So the money that is actually the loan here, we take out the deposit, which is his money, 15,000 that he put, because the cost of the car is 225,000. Then this guy is paying how much? 15,000 upfront, and that's what we call a deposit. And what do we have here? It's going to be 225,000 minus 15,000. We have got 210,000. So this is going to be 210,000. So that's our PV now. So that's the thing. Those are small things to look out for. You look when, if ever the deposit was paid, you must watch out for that. If ever, we'll talk about it. Don't worry. Let me finish this one. I don't want to confuse you. Now let's look at it and see. It's gonna be PV is equals to X1 minus 1 plus our I, the power negative N, all over our I. What is it gonna be in this case here? We're looking for, so it's gonna be 210,000. Okay, and we have got our X there. We don't have 1 minus 1 plus I. What is our I in this case? 0.195 over 12, the power of negative 60. Then here we have got all over 0.195 over 12, like that. So what we can do here, simply do is that take this one here, we multiply with whatever we get here, then we will also divide there. So here we are multiplying, this one we are dividing. Whatever that you get there, we divide it by this whole thing here on top, because we want to get rid and be left with X. So our X should be equal to, okay, so our final answer there is 5,505.45 cents. That's the final answer that you should get here. Let's move on to the last question here and see what we have. Now, Mandy takes out a 10-year loan of 80,000. She repays the loan by means of equal monthly payments, starting 4 months after the granting of the loan. The interest rate is 12% per annum compounded monthly. Calculate the monthly payments. I want to tell you something, guys. Some people say, no, you know what, Stolle, I'm on payment holiday. So you can see here, let's look for this one here. Let's check the picture that I just put here, because this is a reality here. When you are seeing what call cars and car dealers, they tell you that, okay, 3 months, pay after 3 months. You don't pay no deposit, you pay after 3 months. Then you're like, oh, it means that it's a good thing, because I'm on payment holiday for 3 months. I'm just driving the car, but forgetting that the money that the loan here, this 80,000 here, it's increasing for those payment for that holiday that you're telling you about, to say, no, I'm on holiday. It means that after the 4 months, after the 3 months, you are no longer owing 80,000. You are owing something above that, because it's growing for that first time, that the time that you're talking about there. Because remember, the gap should be 1 month, one compounding period in this case. Now, in this case here, let's take it out and see. Well, let's understand in terms of the timeline and understand what I'm talking about here. So this is a 90 days holiday, and this one is a 4 months holiday. Let's see how the holiday affects you guys. Here we have got, what is it? We have got, let's say it's T0 then, T1, T2, T3, T4, okay, goes on T5. Then this is for how long? Pay the loan by means of for 4 months after. Okay, 10-year loan. Okay, so a 10-year loan, so it's gonna be 10 times what? 10 times 12, which is actually T120 there. Okay, now, so if it's paying after 4 months, starting to pay 4 months after granting of the loan, so it means that the first payment here is what? It's here. The first payment is here on the X. That's the first payment after the 4 months. So now it means that we have our gap here. Okay, so it means that the money is supposed to grow for how long? For 3 months. It's grow for 3 months. And it's growing on what? It's accumulating on P1 plus our I to the power of N. So it's growing. So it's first growth. So let's just see. This person here is 80,000 here. Let's just put this one here and values. Okay, our A at T3 is going to be equals to, our principal is going to be 80,000, 80,000 in bracket 1 plus, what is our I? Our I here in this case is going to be equal to, our I in this case, our I is 0,12 over 12 because it's monthly. Then to the power of N, how many here? 3. Let's see what we get there. 80,000, 1 plus 0,12 over 12 to the power of 3. Let's see what we get there. This is what you get, 82,424. So we are now owing 82,424, 08. So this is the amount owed now after the 3 months. Okay, after the 3 months, now you can start paying now. So now when you're starting to pay, that becomes our PV now. This one here becomes our PV. So here we have got our PV, our I, we have it. What is our I? Our I is 0,12 over 12. What is our N? Our N now, N, remember, you are starting to pay when? At T4. So you're going to now to say you're taking out 3 out of this. So it's going to be 120 minus what you call minus what is it? Minus the minus T4 minus 4 is going to give us what? 120 minus 4. What is it going to give us? It's going to give us 116. So it means that here you are starting to make, you are now having N of it's 116 payments. So in this case now, let's just substitute our value there. We know that P is equals to X1 minus 1 plus our I, the power of negative N, all over I. And what is our X? We want the equal payment. It's going to be P times our I all over 1 minus 1 plus I, the power negative N. Okay, that's what we need to understand there. Then let's just try to punch it in our calculators. Okay, just a correction, guys, here on our end there. The payment that were missed is 3 payments here. How many payments? 3 payments. So is T1, missed payments is T1, T2, and T3. So those are the ones that we're supposed to subtract. So we're supposed to say 120 minus 3. Then that give us 120 minus 3 is going to give us 117. So let's use 117 there, what we call in our calculations. Okay, let's use 117 in our calculations. Okay, so I think That's what we need to understand for this class. Our answer there is 1,198.33 cents. Okay, so that's what's going to be paid on a monthly basis. That's our X there. That's our X that should be paid. So I think, guys, you have mastered what needs to be done. So on payment holiday, don't ever trust that, because now it means that you're going to pay more interest in this, should I say more interest? Yeah, more interest. Your loan is going to increase, and again, your monthly installments also are going to increase because of just that holiday that you're telling yourself. So it doesn't mean that when they say 200,000, the cost of the car, and they're telling that 3 months you're not paying anything. But after 3 months, it won't be just 200,000. It's going to be an increased value. Okay, that's what you need to understand. And let's put that in also in practical when you're also making such decisions. Okay, so thank you so much. Don't forget to subscribe. Thank you. Until next time.